Hi OSLO users, this is our fourth video in our Gaussian beams and paraxial Gaussian beam analysis tutorial. So in this video, we're going to get the beam waist into the paraxial image plane. And just to explain briefly about that, or remind you that if you have the beam waist in the object plane, you will not have the beam waist in the image plane. It'll be a different spot size than that. So in order to get the beam waist into the paraxial image plane, we effectively need to shift our source so we don't have the waist in the object plane. And to do this, the magnitude of the radius of curvature should be the focal length of the lens divided by the magnification. And this is something that was discussed in the first chapter, the first video we've done, and it's in our examples chapter that was shown there. So in this video, we have one page of instructions on what we're going to do. So now if we go to OSLO, I still have things set up in the way that I had it set up for the last video, and you can go ahead and keep this surface in if you like or not. There's no requirement to do that. I'm going to try to X out here, and I had actually used our check mark earlier in such a way that I came back to this. This is what I just did, a little bit dangerous. You could also just add those two thicknesses up. You could have saved it and gone back to it, or you could keep the same information in there. I just went ahead and went back to this to show that you can do that. Using the green check mark and red X can be a little dangerous, so make sure you've got things saved appropriately. I happen to like it now that I've used it a lot, but it's always something that some of our users take a little bit of time to adjust to until they learn to love it, because it is actually really nice to have. So okay, let's go back again to our source and ABCD spreadsheet tool here. Again, we're going to enter. Notice that when I X'd out, I lost the information on my spot size here. So we do 0.25 millimeters into the waist size because it wasn't actually specified. You might still have it in yours. Now we need to enter in for the wavefront radius here at the for the waist size there, and this is going to be defined. This is going to be defined specifically at the beam specification surface, which we have as the object plane. You can have cases where you set things up differently if you'd like, but with that wavefront radius there, must have the magnitude of the focal length of the lens divided by the paraxial magnification, the lateral magnification. So in order to do this, we need to get those numbers, and we also have to remember that the focal length divided by the magnification, if via laser theory, if you enter that in, it would work, but we actually need to use the negative of that here, and that's because of the difference in sign convention that OSLO uses with the radius of the wavefront, which instead matches what we use for lenses. So if we go here to do this now, we want to actually first get those numbers that we need. So we go to evaluate paraxial setup again. We have maintained our paraxial magnification of minus 0.5, and here we have a focal length that is given by this particular cell, A39. So if I take A39 and divide by A35 into here, and I have to take the negative of that because of our sign difference. So the negative of A39 divided by A35, and we get something that's plus 1007. That seems right to me. We go ahead and print this now, and you can see now we have the waist that is in the that is defined to be in the paraxial image plane. Notice that our spot size is 0.26, even though we've defined it as 0.25, and the reason for that is the waist is now no longer in that object plane. So we've defined a waist, but we've given it this wavefront radius, which has shifted it away from the actual object plane, but all the numbers still make sense. We still have a paraxial, we still have a magnification here of 0.5 in magnitude. And we are now getting the waist distance is 0, so we've got the same waist size and spot size in the image plane, and it simply means that we've placed our laser in a different location to put the waist coming out of the laser not in our object plane, and that's sort of one of the big punchlines of this video series. You might also want to have a look here at this plot. Now notice we have two solutions here that OSLO is looking at. We're actually looking at the second one with what we're doing, that particular solution. So that's the bottom one, the blue one here. And the instructions don't actually have us doing this particular step, but I'm just doing it here to explain, so it's always nice to do this. And notice that from the object plane, it's a plus 107 millimeters until we get to the waist distance. So that means that the waist distance is inside or closer to the lens than our object plane. So here we've just gone through the waist for this blue solution down at the bottom, and then we move away from that. So the waist size was 0.25, so around that location where we're going through that, you can see it's about 0.25. And then if we go all the way to the image surface, what we have here for the spot size is 0.1322. So it's pretty easy to, as you can see, to check your solution and make sure the numbers do make sense and are consistent here. Now, one thing that we haven't done yet that I promised we would do is try to enter in some impossible value for this. So let's try to enter in 0.5 millimeters. And you can see it says invalid specification of the object space beam. When you see that, it means you are trying to set something up that you can't actually physically realize. And as was explained in the first video, it's because the wavefront curvature never gets that curved. In other words, the radius of curvature never gets to be that small of a number for that particular set of beam parameters. So you do need to be careful with how you're defining your beam, but OSLO certainly helps keep you out of trouble.